Hello students, we are through the difficult parts of our life facing unprecedented challenges, but we are born with special quality to ride over the problems on our way, and let us use this time to learn. I am S.K. Tripathy, sharing my experiences to share your knowledge, to share my knowledge for the first chapter of class 12 mathematics. This is the sixth video. I am coming to functions. Now let us consider two sets, set A 1, 2 and set B 3, 4. Now the Cartesian product of A cross B, the Cartesian product of A cross B Now, I choose any ordered pair of A cross B. Let R1 is a collection of ordered pair. I choose the collection of the ordered pair. Say any ordered pair I choose. Then what I say, R1 is a relation. R1 is a relation from A to B. What does mean? R1 is a subset of A cross B. So, what is a relation? A relation is a set of ordered pair which is any subset of the Cartesian product. I can define the relation R on a set A. Then, what you will get? That relation will be a subset of A cross A. Now coming to types of relations, that is empty relation. Here no element, empty relation. Let A be any non-empty sets. And let A be any non-empty set, then empty relation on A if no element of A is related to any element of A. For example, if you take, let A the set of all students of a boys' school. Set of all students of a boys' school, and relation I define set of ordered pair AB, where A is a brother of B, A is a sister of B. What you see here, in boys' school there is no girls, hence it is a empty relation. Now, empty relation means null relations. No element of a set is related to any element of that set. In a boys' school, if we define the relation that A is related to B, that is A is brother of B, A is a sister of B, then in boys' school there is no girls. So, it is an empty relation. Now, coming to the universal relation, universal relation that if every element of the set is related to each element. If every element of the set is related to each element. Suppose I have taken a relation defined set of the ordered pair such that the difference of heights of student A and B is less than 3 meter. Then it consists of all the ordered pair, because it is the 3 meter, less than 3 meters. It is equal to 10 feet. So what do you find? You find this R is A cross A, that is called universal relation. Now coming to the reflexive relation, every element, obviously on the non-empty set A, if every element of a non-empty set is related to itself, that is A comma A belongs to R, for all A belongs to A. Now here we have to remember that every element is related to itself. Best way to remember some examples to remember this concept. First of all, let us consider the set A, set of all lines in a plane, and let R be defined set of ordered pair A1, and A1 is parallel to A2, where A1 comma A2 belongs to A. Every line is parallel to itself, so it is reflexive. So it is reflexive. Again, if I take that set of all triangles in a plane, and let R T1 comma T2, where T1 is congruent to T2, for all T1 and T2 belongs to A. Every triangle is congruent to itself. And extending this relation, example 3, set up all triangles in a plane and the relation symmetric. Every triangle is symmetric to itself. Now divisibility on the set of integers is also reflexive. Coming to symmetric relation, third type, symmetric relation. If AB belongs to R, implies if AB belongs to R, then BA belongs to R. Example, in the set of lines, relation parallel to relation parallel to is symmetric. Now we will give you some more examples. Say A is a set and R is a relation Now let us see this one. If an ordered pair AB belongs to R, it must be BA belongs to R. Here 1, 2 belongs to R, so 2, 1 is there. 1, 3 belongs to R, 3, 1 is there. But besides that, there are some ordered pairs where it does not affect the symmetric. Now coming to this one, this is reflexive as well as this is reflexive 1, 1, 2, 2, 3, 3. This is reflexive as well as symmetric. Now coming to third type relation, transitive relation. Obviously a non-empty set A is there, and let a relation R defined on a non-empty set A, and if AB belongs to R, BC belongs to R, then A comma C belongs to R. Example, in the set of triangles relation parallel to congruent to and similar to are transitive. Now coming to the relation, equivalence relation. Coming to equivalence relation, if a relation is reflexive, symmetric and transitive, then it is called equivalent relation. Now coming to equivalence class, this is more important. Many students are not able to understand. If you have a set, non-empty set, and R is an equivalent relation defined on A, then this relation divide A into different sets. These sets are called equivalence class. Suppose A is a set 1, 2, 3, 4, 5. I define R, the set of ordered pair AB, such that A minus B is even. Then what is the equivalence class of 1? That is 1, 3, 5. Because between 1 and 3 the difference is 2, even. Between 1 and 5, even. Between 3 and 5, even. Similarly, equivalence class of 2, that is 2, 4. Equivalence class of 3, equivalence symbol is this type. This is the equivalence symbol. Now, equivalence class of 3 is 1, 3, 5. So, what we see here, equivalence class of 1 is equal to equivalence class of 3, that also you can find it equivalence class of 5. Those are viewed, and you must have liked this video, and hope you will share and subscribe, and thank you a lot.